ionization energy is the amount of energy that it takes to remove the first valence electron of an atom. So basically, ionization energy is a measure of how easy an atom loses its valence electrons. Atoms like sodium and potassium, which give up valence electrons to form ions, would have a low ionization energy because they give up their valence electrons easily. So if you think about the periodic table like a rectangle, even though it's not a perfect rectangle, you have rows, or we can also call them periods, that run from left to right. Now, as you go from left to right, the ionization energy increases. So the farther you go to the right down a row, the larger the ionization energy gets. So fluorine has a higher ionization energy than does lithium because fluorine is farther to the right than lithium. Now, as you go up the periodic table, up a column, or we can also call them groups, as you go up, the ionization energy also increases. Now, there's a reason for this. This is because of the shielding effect of inner electrons. For example, compared to cesium, lithium has fewer inner electrons between its nucleus and outer shell. Therefore, lithium has a higher ionization energy than cesium. So an element that's over in this region is going to have a much higher ionization energy than one that's over here, because this one's to the right and farther up in the periodic table. This one's lower and farther to the left. So just by knowing the two facts that ionization energy increases to the right and as you go farther up the periodic table, you can just look at an element, look at where it's geographically situated on the periodic table, and get an idea of how high its ionization energy is when compared to other electrons. So the important thing to pull out of this session is that ionization energy is the amount of energy that it takes to remove the first valence electron of an atom.